Here is the feedback or walkthrough for Lesson Plan Evaluation 2. These I know are pretty exciting videos and they're really well done. So, kudos to my production team. Anyway, so when we look at this next lesson plan, we have a learning objective of students will be able to describe each state of matter in terms of its molecular structure. She's going to go through, or he or she is going to go through 4 different states of matter and also going to define molecule. Introduces different states of matter, asks them if they know what a molecule is, ... Explanation, talks about solid, liquids, and gases and what those molecules look like. Guided practice, interactive modeling. They get together and do kind of a fun activity where they demonstrate gas. Could be fun. Might illustrate the idea for some, extends it, and so on. Independent working time, they play with goop, and it's kind of a tweener, not really, kind of like, if you've made the cornstarch mixture before, you know that when you press on it, it kind of becomes solid, but then when you let it rest, it kind of falls apart. So it's an interesting thing. The key thing is that, right, what do you think the molecules in goop look like and why? What state of matter do you think it is and why? And so she's trying to get them to investigate and do inquiry-based learning and so on based on what they know. Enrichment activities, right? If some kids, I guess, finish this quickly and want to go further, they can research colloids in plasma, and maybe then they can identify this correctly as a colloid. Support means that they can just use notes as they answer discussion questions. So I guess that is a support. Assessment, give them an index card and they describe the molecules in each state of matter without using notes. And I'm assuming she's meaning solid, liquid, and gas, not colloids or plasma. But should clear that up, of course. Review and closing, ask students to share their response to the discussion questions, explain that the goop is a colloid, which is kind of in between where you have solid particles suspended, so on. Give other examples, ask if students can think of any other colloids, and so on. All right, so that's the general idea of the lesson. First question, to what degree does this lesson possess alignment? Now, I say that everything from the objectives to the activities and instruction and the assessment all are in alignment. I guess you could be nitpicky and say that maybe some of this goop stuff isn't really great, but when you're trying to give them or extend or deepen an idea, right, a lot of times you have to give an example that doesn't really fit in any of the things that they know. And so you're pushing their knowledge and their understanding. So I think it's actually a very good way to introduce the idea of colloids. And so on. So I would say that all portions are in alignment. If you disagree, let me know. Learning progression. I would say that this lesson also builds things pretty intentionally from the idea of getting the ideas down in the basic sense of what a molecule is, what are the different states, what do the molecules look like, some examples, applying it to a new situation that doesn't quite fit. Again, whole inquiry-based learning idea. As far as differentiation goes, that works. The assessment at the end, and then the closing where she does extend their knowledge to this 4th state that students probably didn't know. But I never learned about colloids and plasma even through high school. Never heard of it. So that's great. If we go through the next one, meaningful context, again, she does give some examples. And you could argue that's kind of relevant, but the key idea here is that you want to give them some understanding of why this matters in real life. In the animal symbiosis thing, right, it matters to think about the different types of relationships you're in and what kind you want to cultivate. So that helps there. In this case, though, there's no real justification for why it's important to know whether something's a solid, liquid, gas, or colloid, what those properties allow things to do, why they're necessary for life, what that has to do with your body or your home or anything like that. So there's no real meaningful context provided here. And if you can think of one and you want to run it by me, again, shoot me an email and let me know, and I'll respond to the entire class. If we go to differentiated supports, again, I would say that in this case, you have students research other states and share their findings, have students use their notes to answer the discussion questions. I would say that the enrichment works pretty well in the sense that you are extending their knowledge to other types, so that works. The support, however, right, students using their notes to answer the discussion questions, likely it will be the case that the students who would need to use their notes didn't take very good notes. It might not help them. There should be some other materials or activities that the students could do that would jog their memory. Maybe some kind of group composition thing. I'm not sure. You could do a lot of different things. But I would say that 2 is the best. If you could want to stretch and say that these both work, you could go with a 3. But again, I just don't think the support is quite up to snuff. As far as targeting misconceptions, could have, if they opened up with talking about how many states of matter there are, right? And at the end or during the lesson, she might or he might say that, well, most people think that there are 3, but there are actually more. And we're going to talk about those. So in that sense, right, misconceptions aren't really targeted. Again, that is doing it proactively. You could argue that at the end, there is a closing. However, in order to have there be more evidence that it was actually targeting the misconception, it should be more explicitly stated within the lesson plan, both the purpose of why they're doing what they're doing and how that misconception is going to be righted. If you go with using student assets, again, 2 components: prior academic learning or personal, cultural, and community assets. I would say that in this case, you could argue that asking them what a molecule is, and trying to get them to remember what you might have talked about in another class might be okay. As far as interests go, right, the activity with the group, kids do like hands-on learning. They do typically like playing with things like that. So that would be a personal asset where kids have this interest and they're going to think that's fun. Tying that to the whole idea that there's another state of matter that we haven't discussed so far works. So I would say that that one works. The prior academic learning isn't really there because it doesn't say that review what a molecule is and so on, right? That would be better evidence that prior academic learning is being activated. Just asking them could get you there, so you could argue a 3, but I would say that a 2 is a better fit. Finally, planning assessments. The lesson plan includes a well-aligned assessment at only 1 point during the lesson. It does have an assessment at only 1 point. It is aligned, and so it is a 2. There aren't any other assessments, even though you could say that monitoring group progress and so on would work. If it's not in the assessment section, don't count it. But that's it. If you have any questions, again, let me know. There's another one for you to do online, so make sure you do that and justify your responses. I will respond to how people answer and kind of highlight everything that I think needs to be highlighted going forward. Thanks.